Welcome to the physical work video for the sensors, effectors, and actuators part 1 notes. So again, we're continuing on that this is focusing more again on the analog and digital signals aspect of it that we've covered in lecture videos and the simulator. Please, if you're just watching this video and you haven't watched the simulator video, please go back and watch that first. It gives you some extra explanation for some of the craziness that you're seeing here. But as we continue on now with the physical one, I will be introducing slight differences if you're working with the kit when working with some of the equipment, and just seeing what is it different that when you're working with the physical equipment versus the actual simulators. So I have a couple different circuits that are set up here and some that aren't fully everything working together, so variations of the program, and all of this code is up on the actual course drive, and you should be able to have access to it, and it's easy enough to figure out how to hook everything up. So first off, I have three things kind of set out here. Is that I have an RGB LED right here that came with the kit. Now be aware, when we did the simulator video, that was using an RGB that had a common cathode, so connected to the negative. The ones that come in the kit are actually a common anode. So you'll hook them up the same way, but the difference is that for that shared longer line, instead you are connecting that to the power. And if you go into the FreeNova tutorial that you can download from the FreeNova website, or if you go to the course Google Drive, you can see the FreeNova zip file there, which has a tutorial file in it. There is an entire tutorial where they go through using the RGB that's in there. So again, the difference is that you have to make sure that you're hooking it up to power, and then there's a difference in the actual code itself. So we have an RGB kind of setup right here. There is also a setup for analog input using a photoresistor connected, and it's connected to analog pin. And then a new thing here that hasn't been introduced yet as a component, and we brought up again in the future, is called a potentiometer. So it is a variable resistor that has this little knob that you see that's right here. Is that knob then allows us that when we change it, that as we dial it, it changes the actual resistance and kind of gives us an analog signal or a different way that we can use that as input. So for this first circuit that you see going here, neither of these two actual things that are set up as analog sensors are doing any actual work. That's in a variation of the code. This one here is just going through showing a basic fade example that uses the for loop kind of version that we saw in the original in the original simulator version. So for connecting everything up here again is you have the three resistors. In this case, I'm using 220 ohm K resistors, which work fine here. This light is bright enough for it. The breakdown for the actual RGB LED is that there's going to be a slight flatter side, but when you pull it out of the kit, you'll see that there's one very long extended prong that's coming from here, and that is your common anode. And then the one that's right next to it that should just be a little bit shorter is going to be your red, and then you have your green and blue. So it's hard to show coming from here, but you can see that from the one side is that this little one that's in between kind of pointing there is the common anode. Then you have the red next to it. On the opposite side from it is the actual green, and then you have the actual blue. If you look in the tutorial booklet, it also shows that as well from the FreeNova of how to read and set these up. I've got corresponding colored cables to make it easier for myself to know what's connected to what pin. So blue light, green light, and then the actual red light here. Red for power, ground, and everything that's actually shared coming in. The potentiometer that's set up here has just 3 pins where you have to run 5 volt through one, and then the opposite one you run the ground, and then the very middle pin you connect to as your analog input. So you can see the longer blue line that's going over here to our actual analog input pins. And interesting fun that can come from there. So I'll go through the code for this and just shrink that down to the actual side. Now, I'm going to go through this and maybe a little bit fast, but I still suggest you take this code and you play around with it. And this code itself has a couple different demos in it, and I have just basically commented them out, and I have different functions in here to allow you to play around with what we're doing. So you have your common constants that I suggest in the beginning just to make it easier to know where you're connecting the pins and readable. We have the beginning, so we can do serial communication because I'll be demoing the serial monitor and the serial plotter right here. And then the output pins for output, and then turning all off the RGB. So this is a similar function to what you saw before. Now be aware this version of the code works with the RGB that has the common anode. So there's slight differences when it comes to the code that you saw that's working with the common cathode. We have the fade up code that is going from 0 up to 255 by increments of 1 and doing an analog write. Now this 255 that you're seeing here is because of the common anode, we have to actually reverse the values. And so by putting 255 here, you know, if the other value was 255, we're going to get a 0 coming back from this. And also be careful that when you write a 0, it also means for these just to turn the power on as brightness. This is the fun of working with the physical components, that you have to understand these weirdnesses of it. Okay, I have the RGB. So this function here is similar to before. You can just leave your RGB values you're used to, and I've set it up so that it automatically reverses it, so that 255 minus the value will flip it. Everything else that you see here is the same, but this first RGB demo is doing what you saw in the simulators, but now doing it with the physical equipment. So, and it'll be outputting to the actual serial monitor at the same time. So we fade up the red pin, then we fade up the green, fade up the blue, wait a second, then set the RGB to be that yellow, and then wait 2 seconds, and then set the RGB to be pink. And you're really going to see compared to the simulators in here that the colors don't match up perfectly, but that's the idea of the lighting I have within here, the camera itself, and just the quality of this LED. You can get better quality ones, but again, this is a cheap, basic one that we're working with here that allows us to do some work. Okay, so for this first one, I'm just going to demonstrate the actual serial monitor. You still see the code running over here. I can even just go and re-upload this exact same code we have here. And you'll see the Adreno flash in the TX, RX as it's transmitting over the serial communication, and then as it restarts up. And don't forget, at any point in time, you can also come and just press the red reset button on the Adreno. And what that does, it's basically like turning it off and on, and it restarts the entire program as well. So if we have this running, I'm going to open up the serial monitor. You have one case of pressing right up top here, this button, or you can go to Tools and you can see the serial monitor and you can see the serial plotter. So I'll open it up here. And it'll open up another window for you. Just give me a second. I got to move this window over. Okay. Let me just open that up again. Apologies, there's multiple monitors. And you can see the serial plotter now here running. So I'll put it over here. Now, in this case, for the version of the serial monitor that I have in my Adreno IDE, I have the auto scroll, but I also personally tick the show timestamp, so I can just see the time as the signals were actually coming in. And I've already got the baud rate set properly, so the exact same that I have in my code here. And here I could even clear the output if I want to right now. Otherwise, as things come up, so you can see as it's matching up from the code of fading up to blue, then showing the kind of yellow, then the kind of pink, which looks more white here, and then going back to the fade red. So a nice way for here, again, just using the serial monitor as a way to kind of debug your code, know some steps of what's going on here. So nothing too big in this example. Similar to what you saw already in the actual simulator video, but it's now the physical work and the fact of now showing the RGB that has a common anode instead of a common cathode. So being that one line that's coming out. But also demoing the live part of the analog signals, that PWM coming into play, that's mimicking the analog signal, that you're now getting that fading of the light going up to brightness to darker. And even though this doesn't show here in this code, is how you could have it fade between colors and get different colors as you go in nice gradients that maybe we'll see in future videos. So in the code I have here, we can next now to stop this. So can comment out the one and bring in the next. So what I want to show next is kind of using to do calibration of stuff, something I didn't talk about in the simulator videos. But the fact that when you're working with the photoresistor, it's not going to always give you values from, say, max brightness up to 1024 and the lowest values down to 0. If you wanted to get mapping and kind of reacting a little bit better to the values, you need to calibrate to see, well, what is the lowest value and the highest value that it gives you for your setup, which is always going to change, and you have way more fluctuations here. So I wrote this little calibration function that you give it a pin, and what it does is that I just have two global variables here of max and min. I have set the min value to just one really, really high value right here. So 200 being like higher than what you'd roughly expect to come in. 0 should be 1024. So this is the highest possible value you could have coming in from an analog pin. And then here the lowest. So like these kind of values that are out of range, that if this is the min, anything should be smaller than this. If this is the max, anything should be higher than this. And the idea of what this function is going to do is it's going to keep doing reads, and then it's going to check and see, is this new value or the max value, which is the largest, and then return that back. And the same thing here, which is the smallest, return this back, and keep outputting this. And what this allows us is to start seeing what's the minimum and what's the maximum value overall that we see coming out from this actual sensor itself. So here I've got the analog pin for the photoresistor set to A0. And passing that in. And if we go run this, I want to have the serial monitor open already. Give me a second. Okay, sorry about that. Still, this is showing us the previous one. I'm just going to clear it here when I have it go, but I am going to upload the new code for right now, which is going to go into the actual calibration. So we've now uploaded the new code, and now we're getting values coming out of here. And now these are the readings that are coming off of that photoresistor. So the min and max as seen. So nothing's happening right now because I'm not near it. But if I start putting my finger over top of it, you can see like, okay, well, seeing less and less to, okay, well, I got lower values versus the actual brighter. Versus, say, if I move it. So the idea here is it's what light level it has. I actually have like 2 to 3 different lights on this right now, and it's what this actual photoresistor is seeing. And I'm just doing this to calibrate to see, well, what's the lowest? Even if I cover completely with my finger right now with my current lighting setup, it's getting only like 149 as the lowest, and then 606 as the actual maximum. But these things can change because really it's this flat surface. So even if I lift this up and turn it towards one of the lights I have, you can actually see that max values that it's getting. So I'll put it down. It's found a new max, but that's just because I had lifted up, and the idea is you off camera, you're not seeing this here, but I have another light directly this way that's looking for. I also have another light directly this way. So these are just the max values that are coming out of this. And so for me, what this tells me is, okay, well, I have 149 and 600 and actual, like, 30. So, like, it's not actually going between, like, that's the minimum value. So if I want to map and just have these changes, I know, well, here's the minimum and here's the maximum that I have coming in. And I know the range then I should be roughly expecting based on the site set where I am. And I can maybe shorten that range of mapping not from 0 to 1023 up to 255. I can shorten it, and so that we have more, like, responsiveness coming from the actual photoresistor. So hard to see now, but it'll be a little bit more when we come to doing this next one. I'll come back to those values that we were seeing, and we can recalibrate it. Instead, I have another function that does an RGB demo, and basically it hooks up an analog pin that we have here saying this pin, and we have the min and max values that should be expected off of that, and then it fades the light based upon the input coming in. So that's this function here. So it does a reading off of that analog pin, just prints it out so we can see it and also use it in the serial plotter. And then we use a mapping function just to quickly change it between reading between the min and max that we've passed in to the range we should have for PWM. And then outputting it for the color and then doing an actual delay. This one right here is if we're going to reverse stuff, but we'll see it later. So now if I upload this code to the Adreno, here, I'll just clear my inputs so I'm not seeing anything else. We can see there's tons and tons of quick values, mean nothing, but this is the reading of the actual light. And so you can see the RGB LED there, and if I use my finger to cover it, you can kind of see the values dropping there, and then the light itself kind of getting brighter and dimmer as I get closer and different lights, or if I pick up the whole thing and aim it towards the actual light. The idea is, again, that we're reading those values from right here. Now, here's this case where using the serial monitor does not really help you. It's hard to visualize what's going on. So this is where, since we're outputting it just as those single values, it'd be a lot better to start using the serial plotter to view that data. So we open up the serial plotter. I don't know why everything has to keep coming off my main window, but here you go. These are the values that it's actually reading for right now. So weird, this wasn't even when I was testing it doing these things, but probably just because of the initial values that I had. So now we're seeing that's that same sequence and stream of actual numbers that were coming in from right here, but like anything I am doing now, even close to blocking from this light, is popping in. So there's variations that we're not seeing in the actual like LED, even though it's going up and down. It's hard for our eye to see. We can now see the actual analog signals that are being sampled coming in. So even as I'm doing nothing, so my hands, like I'm further away, like you're not even seeing me on camera, but like you can see those fluctuations that are popping up now and then suddenly going back. That's me moving my hand even just slightly close to the actual light and how it's blocking what the RGB LED is doing. So that big drop is my hand's just like literally moving right in front of the light off camera. So if I bring it in here, my hand here, you can now see like here, if I can specifically, we can see, oh, I'm even this as my input. My hand is then controlling this, and it's changing this light as the input, which could make for an interesting way to use very simple photoresistor if you're connecting this to some other way to try to interact. Because you can see even as I move my hand, it's also then changing these levels of the signals. But right now, it's hard to see as much of these fluctuations because if we're looking at the graph, we can see the max light. We're seeing that 603 and these random variations and craziness happening. And then say, even if I cover this completely, if it drops down, we're only seeing back to that 150. But I said before that my max, and you can just see it going crazy here as we get these values. Okay. And there's the jumps and this thing auto slides. You can see like, well, that 0 to 1023 just didn't work good. Like that just did not work good for doing a proper mapping, and the light's not changing enough because we're only getting these max kind of ranges. And so the idea is that that's why that calibration thing is that I could run it and then kind of get a min max, and could have kept playing around and it would have found them for me and just outputted that. And then I can go modify those. So even to make this say a little bit better for right now, I'll stop this plotter. We'll go back to this code that's here. And instead of having 0 as the min, I'm going to up that to, I'm going to say 120, because it's roughly the minimum that we were seeing before. And then the maximum, like it was 640, but I'm going to say 700, because this is just my light rig here. Your own house and the time of day, you're going to have to do it differently. I'm doing this currently at the middle of the friggin' night. Doing the video, so it's dark everywhere else except for my lighting setup. So now if I do this kind of range for the mapping, now, so when it comes up here min-max, it's going to be a little bit tighter, and there's going to be more fluctuations for what you can see in the actual LED itself. So let's upload that. Get it going, open up the serial plotter. Okay. And now start making some changes. And you can see this time as we're coming closer, that LED is fluctuating and light levels a little bit better. Let's say if I even move away one of my lights, which is gonna like make this LED react, and say even more if I turn off another one of my lights right here, it's gonna instantly drop. But there's still enough light in the actual room. Let me bring this back because they're blocking it, so getting a little bit more light. But now you can see it a little bit better in the amount of light and fluctuations of what you're getting. Not like perfect, but that's where you'd have to keep calibrating this and getting this into a range of what you're working with for that sensor itself. So boom, let's bring back all the lights on, so instantaneously let the camera like settle back in. So that's with that one pin that we're working with. Okay, so I'm going to leave that running just here in the background. You can ignore this, and so even though I'm doing the code, the Arduino's still running until I put in any new code. So I just want to put this back to the original for right now. 3, and I want, oops, I'm going to comment it out. And I just want to go down to the actual potentiometer. So this next function here is if you want to calibrate the potentiometer, but you don't need to do it so much for stuff because we are working now with something that it's a little bit more discrete. It's not as much discrete values as the actual light resistor itself. Is that this potentiometer right here is that when you dial it, it's a little bit more like controlled for what it's doing. So in this case, again, this thing here itself, so if I angle it up, you can see the demo's got 3 pins, you've got them in the kit. Potentiometers come in different sizes, but the idea is that they'll change the resistance as well, but based upon these sliders of where you have it. So we'll go from 0 to 1 or 2 to the max resistance that you have hooked up. And so it's a way that we can use as analog and have discrete settings, and it'll stay at that setting where you left it before. So, and basically dial in knobs that you're using. So now if I switch and upload this code now, it'll start outputting stuff to the serial plotter the same way we had before, but this time the analog signal is coming from the potentiometer. So right now it's set, the LED is doing nothing, but I have it turned to the far one side, so it's 0. But if I start turning this the opposite way, you'll see the graph go up and you'll see the light go up. And it's consistent. You can still see the little jitteriness that's in there. This is, don't worry about that, was the graph just settling because I haven't actually changed it. But you can still see as I touch or even do stuff, there is like little jitteriness in the actual signal, why we don't get exact values. And that's from that sample and that reading in, and even other things that are affecting as we come near it and touching anything. But if I change the knob now, going from the bottom and then going to the top, so to 1023, is that you can see it's basically like I can dial in specifically what color I wanted, but watching the signal, even if I say keep turning it back and forth and back and forth, you can see how it stays a little bit more controlled, definitely compared to the light resistor if we want to use this to dial in specifically. So say like settings and stuff coming from a user or other controllers where you had to turn to it, and we could detect and know that roughly exact where have they turned this to as a dial knob. So fun to play around with. One thing to note, especially with the physical things, is if you're not careful and you touch different things. The front of this is metal, but this back side here is metal too, and you can watch, it's not changing. If I'm not changing the potentiometer, but if I touch it, let's see, oh, that's at 1000, so it won't change much here, but if I touch it here, oh, let's watch it not do it this time to me. Okay, leave it for a bit, and you can see nothing's happening, touch it. Notice the spikes, not touch it. So you can see, there's me touching it, here's me not touching it. Here's me touching it. Here's me not touching it. So issues of working with the physical equipment is that you don't know these little things that could be affecting it. You're touching it. And look at that. Look at that. Like my hand is not even near that right now. And I'm not even, but look. Now in reality, this could be other weird things that I do actually have the photoresistor hooked up from right here. And this light is over top of it. Yeah, isn't that weird? Let me even better to see from right here. I'm going to disconnect, which is the white, is the photoresistor from the circuit at all. and wave it over. It's like still, it's screwing this up. It probably won't happen for you guys. Something I haven't mentioned is I actually have like magnets embedded in my hands. It's a different body modification. And so I'm not even sure, like, why would that affect it? Why would this, me just putting my hand and waving it over near the potentiometer, start changing things? But I have a magnet in the side of my hand there. Hard to notice, but let's see if I can get something for it to stick. Okay, you can see there. Oh, look at magnet, it's stuck to my hand. That's actually a magnet in there. And magnets will affect circuits. So I have a good feeling that because I have magnets in my hands that this is screwing stuff up. But the fact that weird things can happen to circuits, seeing the potentiometer, anything, me being near it, waving it, changing the actual field, but the fact that there is an electromagnetic field that's around this that could start affecting stuff, and you have to worry about that for your values. You won't see it in this RGB LED affected as much, but maybe something else, and you need to filter that through. But also the fun of playing with the plotter, that you wouldn't have seen these in the actual numbers. I don't know, it's just sometimes cool just to see the damn graph. So in the code itself, you see these basics. So this is not as long of a video for like the physical work, but I wanted to show you some different devices. Hook this up, the potentiometer for the people working the simulator. You can play around with them as well. But I wanted to demo you some weird things that can actually happen, different things that are going on. But you should go past this point and actually start hooking the stuff up. If you have the physical kits, it's much better for you just to start playing with these things, get that hands-on experiential learning that I can't give as much if I was with you guys in the classroom. And so that's why I think I'm going to stop here right now to half an hour. That gives you enough material, but giving you more time this week that you should be sitting down, playing with this material, and contacting me if you need any extra help. So other than that, like every other video that I ever end, I hope you're doing good and you continue to be in good, and you remember to take care of yourself and doing what you need to do to help other people around you, and maybe try to make little changes every day to make this world a little bit better of a place. And if nothing else, love yourself a little bit more.